Hello students. In today's video, we will learn about two important terms of motion, distance and displacement, and how these terms differ from each other. Let's say this is the view of a park from the top, whose length is 40 meters and width is 30 meters, and your house is here, and your school is at the other end of the park there, and there is a road all along the park. Now let's say you travel to your school like this, along this road, and then along this road. So what will be your distance? Distance is defined as total length of the path traveled. So in this case, you traveled 40 plus 30, which is 70 meters. So 70 is your distance. Now how do we calculate your displacement? Displacement is defined as the shortest distance from the initial to the final position. Your initial position is your house, and your final position is your school. So what is the shortest distance? Yes, you guessed it right. It's going to be a straight line from here to here. So how do you calculate the displacement? Can you see the right angle triangle here? That's right. So we can apply Pythagoras' theorem because the displacement is the hypotenuse of this right angle triangle here. So the displacement is going to be square root of 30 square plus 40 square. If we further solve it, we will get 50 meters. And as you can see, it's less than the distance, as displacement is the shortest distance and not the total distance. Now let's look at another example. When a ball travels along a circular track from point A to point B, the distance is half of the circumference of the circle. The displacement is the diameter of a circle, and its direction is from A to B. Then the ball travels back to point A. The distance is the circumference of the circle. In this case, the displacement is equal to 0, because the ball has returned to its original position. So from these two examples, we can deduce that distance is always greater than or equal to magnitude of the displacement. Can you tell when both distance and displacement will be equal? Yes, you guessed it right. When the object travels in the straight line without reversing its path. To help you understand the difference more thoroughly, imagine starting at point A and walking a distance of 3 kilometers. Depending on which way you set off, you could end up in any direction. This is because distance doesn't actually give us any idea of the direction, which is why it's a scalar quantity. However, if you'd started at A and then told us that you walked 3 kilometers east, we'd know exactly where you ended up because you gave the exact displacement, which is a vector quantity, as it has both a magnitude of 3 kilometers and the direction of east. Imagine a taxi starts its journey and picks a passenger at point A. It travels 5,000 meters to point B in a straight line to drop off the passenger. After dropping off the passenger, the taxi returned 3,000 meters to point C, which is somewhere between point A and point B. Now let's think about what will be their distance and displacement. So the total distance the taxi traveled is the sum of the distances from point A to point B and from point B to point C, which will be 8,000 meters. For displacement, consider the taxi's starting point at A and its final position at C. Displacement is the shortest straight line distance between these 2 points, which will be 2,000 meters. Remember, distance is the total path traveled, while displacement is the shorted path from the starting point to the final position. In the next video, we will be covering other important terms related to motion like speed, velocity, and acceleration. So stay tuned. See you next time.